Hello everyone, this week we're going to be talking about hacking wireless networks. So in your chapter reading and in the presentation today we're going to talk about what various wireless technologies exist, wireless networking standards, the process of authentication, the process of Wardriving, if you haven't heard of it, and wireless hacking tools used by hackers and security professionals. Again, security professionals are hackers as well. So what is wireless technology? Essentially, it's network over a radio. So for a wireless network to work, you have to have basically the correct hardware and software. And wow, what is this book? Apparently thinks it's a physics textbook. Essentially, you're taking radio waves and translating them into a communication device. You see wireless technology everywhere, cell phones, GPS. Again, all this uses various radio frequencies to transfer data between devices. So what are the components of a wireless network? And again, a lot of what we're talking about here is specifically the 802.11 standard. So you can think 5 gigahertz, 2.4 gigahertz bands. That's not to say that we won't talk about Bluetooth a bit, but for the most part, when we're talking about wireless networking, we're talking about those major bands. You have wireless network interface cards. These are transceivers. Transceivers transmit and receive, hence the name. And access points, they bridge wired and wireless networks. There's various wireless networking protocols, and as I said, the portion of the radio frequency spectrum. Again, in this case, for the 802.11 standard, it's 2.4 and 5 gigahertz. So access points are, again, transceivers that connect to a network via an Ethernet cable, and they bridge the WLAN with the LAN. They're not all connected to a wireless network, but most companies use WLANs connected to wired topology. Access points are where the various RF channels are configured, and it allows people to connect to a LAN using those wireless protocols. Here's an example of wireless channels that are detected on a wireless network. So SSIDs, Service Set Identifiers, they're the name that is used to uniquely identify a wireless LAN, and that's configured on the AP, and it's a unique 1 to 32 character alphanumeric name that is case sensitive. You have to configure an SSID, but SSIDs can be broadcast or hidden. But even though it's hidden doesn't mean it's actually hidden. It's more security through obscurity. You can still get the SSID even if it's hidden. So don't think hiding your SSID is going to solve anything. Here's an example of various default SSIDs that come with various vendor hardware. So when you're configuring an access point, configuration varies depending on the embedded operating system. And we talked about embedded OSs a few weeks ago. A lot of them offer access through a web browser. Many of them still don't offer it through HTTPS, and even if they do, they a lot of times don't offer a valid certificate. DDWirt, you can reconfigure a wireless router to run DDWirt, again, as a different layer than the firmware provided by the vendor. So again, here's an example of viewing status on DDWirt. Basic wireless configuration. And configuring wireless security. So for wireless NICs, if you're going to get wireless technology to work, each node or computer has to have a wireless NIC card. This converts, obviously, the radio waves back into the digital signals, much like the access point hardware does. And there's lots of different wireless NICs on the market. Again, most of the times these are built into modern hardware. So it's you don't oftentimes have to go out and buy a NIC card. So wireless network standards. Again, what's a standard? It's a set of rules formulated by an organization. IEEE, Institute for Electrical and Electronics Engineers, handles the wireless 802.11 standards. The working group, the WG, works on that. And if you see letters A, B, AC, N, Z, these are all approved projects. You can almost think of these as RFCs issued by other organizations. These are sets of rules that should be followed by software manufacturers, hardware manufacturers when building out equipment or software to adhere to those rules. 802.11 was the first wireless technology standard. It defined the specs for wireless connectivity, and it applied to the physical layer of OSI. The one assurance that the standard gave was that it avoided network collisions. So we don't go into depth in this course, but in your other networking courses, you probably talked about carrier sense, so CSMA-CA and CMSA-CD. I know that if you're studying for instance, your CISSP or your CCSP, it's a major topic. So remember that it strives for collision avoidance. Again, it's not a for sure thing, but as part of the design, that is part of it. So wireless LANs don't have an address associated with a physical location. Instead, every addressable unit is called a station or an STA. So in 802.11, you have a basic service set, or BSS, that's the main building block. And then it's a collection of devices that makes up your wireless LAN. And a BSA, or a basic service area, is the coverage area around an AP. So if you sweep a circle around an AP, a lot of times it's not a circle because, again, it depends on how the signal interferes with the physical material. So if you have concrete or drywall walls, theoretically, if you had an AP sitting in open air, there would be a big circle around it. That would be your BSA. If you have it in a building, usually you would do a site survey because that's going to be an odd kind of 3D volume of space that represents your BSA because, again, it travels through materials, reflects off of materials, etc. A WLAN running in infrastructure mode always has one or more APs, and an ad hoc network, which was used by a lot of hobbyists when wireless LANs first came out and wireless NIC cards were available. It's an independent wireless LAN without an access point. As long as a station is within its BSA, it can communicate with other stations in the BSS. And to connect to BSSs, 802.11 requires a distribution system intermediary. So BSS1, for instance, if it was a BSS, connects to the distribution system, which in turn connects to BSS2, and those two BSSs communicate through the distribution system via the access point. So here's an example of connecting to wireless remote stations. 802.11 also defines the operating frequency range. So I mentioned 2.4. So it's really 2.4 to 2.4835 gigahertz. Later versions of 802.11 use the 5 gigahertz channel or 5 gigahertz band. So when we talk about 2.4 gigahertz to 2.4835, these are subdivided into channels. The reason is because, again, when we talk about collision avoidance and interference avoidance, you have to separate these bands into these subbands into channels, so that APs using different channels, their emissions don't collide and interfere with each other. And because of just the way RF works, you have to have certain spacing between these bands, because when you emit them, it's not perfect. So you leave enough room between each of the channels. So, take 2.4835 minus 2.4, so you have 0.0835 gigahertz divided by 11, and the center point of each of those represents the theoretical frequency the channel should be operating on. But remember, again, RF emissions are not perfect, so it may vary from side to side. Emissions may leak from side to side. So from a technical standpoint, that is how it's divided, again, with that whole concept of interference avoidance in mind, collision avoidance in mind. If you're not a radio person, if you're ever on ham radio, my call sign is Kilo 8 Charlie Lima Echo. How does this all work? The amplitude is the height of the sound wave. So remember, when we talk about radio frequency, they say sound waves here, but essentially it's a electromagnetic emission. Sorry, it's early on a Sunday morning. Your amplitude is the wave height. Your frequency is the rate of repetition. Your cycle is the time it takes to do one full round of a repeating pattern. Hertz is the number of cycles per second. And when we say band, it's various frequencies. Here are our basic frequency bands. VHF and UHF, for example, in television. Represent a range from 30 to 300 megahertz. So your wavelength is 10 meters to 1 meter for VHF, 1 meter to 10 centimeters for UHF. So when we talk about the 2.4 and 5 gigahertz bands, that ends up in the SHF frequency band. So an overview of wireless technologies, IR technology is another example. Again, these are all waves, right? So it just depends on what band you want to use. IR can be used as well. It can't be seen by the human eye. It's restricted via line of sight. It can't penetrate walls. Also, there's a heat issue. If you keep blasting IR at something, just the way the universe works, I guess, it starts rattling those atoms and those compounds and generates heat. So a lot of times IR is bad microwave as well, which is why when we talk about 5G, everybody's going, you're going to cook my brain, because it acts like IR, right? Just that specific band, for whatever reason, however the universe was designed, tends to cause vibration mechanisms in atoms and compounds to occur, and it generates heat. So narrowband uses microwave radio band frequencies to transmit data. Cordless phones, garage door openers, and then when the TSA is scanning you with the millimeter wave machines that cook your brain. So an overview of wireless technologies, again, spread spectrum. So modulation defines how data is placed on a carrier signal. So data is spread across a large frequency bandwidth instead of just traveling across one frequency band. So again, if you've been studying for any of the networking exams or even some of the cybersecurity exams, you're going to encounter some of these methods. FHSS is frequency hopping spread spectrum. Direct sequence spread spectrum, DSSS, and orthogonal frequency division multiplexing, or OFDM. 802.11b, i.e. Wi-Fi. Again, there's since this slide was created, there's been a lot more than 802.11b. So B operates in the 2.4 gigahertz band, and it can pump data up to 11 megabits. That is per the specification at the time, because of the algorithms being used and the assurance that the protocol would avoid collisions and ensure packet integrity. It was capped really at 11 megabits, but that is not the theoretical cap of data transfer over that frequency. The standards allow for 11 channels, but only channels 1, 6, and 11 can be combined without overlapping and creating interference. And we talked about, again, the 2.4 gigahertz band, subtract the 2.4 from the top band, divide that by 11. And again, because of the behavior of some of those frequencies, we talked about the interference patterns. So you have to just, kind of, if you want to learn more, dig into a bit on RF. This also introduced a new feature called WEP, Wired Equivalent Privacy, which wasn't. WEP was a first attempt at saying, okay, let's try to encrypt some traffic. Let's keep our data from being sniffed. Yeah, that was broken almost instantly. 802.11a, again, 5 gigahertz. The standard throughputs were increased to 54, and same with 11G. Using this modulation, again, using different algorithms allows you to increase that throughput while maintaining the original goals of the standard. 802.11i introduced WPA and fixed some of the security vulnerabilities in 802.11b. E was interference improvements, and N, just like G, allows you to use multiple antennas. AC, 5 gigahertz. This was your first protocol allowed up for 1 gig a second, and then AD, WiGig, allowed for 7 gigabits per second over 2.45 gigahertz and the 60 gigahertz band, which was introduced later on. But again, as you increase these bands, when we talk about 60 gigahertz, you have to be right next to that AP for it to work. Whereas 2.4 allows for a longer distance. I mean, you even talked about back in the day using Pringles cans, which are lined with foil as key antennas to grab wireless networks all the way down the street. You can 2.4 gigahertz, because of the way the spectrum works, you can use directional antennas and pick this up pretty far, whereas 60 gigahertz, you don't have that same luxury. It starts to degrade after short distances. 802.15 is Bluetooth, or WPAN, and then 802.16 was wireless metropolitan area networks, or essentially mesh networks for large areas. 802.20 was mobile broadband wireless access for mobile. So when we talk about being in vehicles or transports that go super fast, how do you switch between networks but still maintain uptime and integrity? And here's a summary of some of the approved wireless standards. All right, authentication. A huge concern, obviously, when you're in security. And when you talk about wireless technology, you're inherently talking about some potential for security problems. So we talked about 802.1x. This defines the process of authenticating and authorizing users on a WLAN. So we have you have your typical point-to-point protocol. You have EAP, you have PEEP, WEP, WPA, WPS. These are some of the concepts and terms to understand as we get into this. So point-to-point protocol, if you're using a modem back in the day, PPP was the way that users were verified, the way that you were authenticated into the remote network. EAP was an enhancement to PPP. It allows various authentication methods, and it introduced the use of certificates. So here's an example of an X509 cert that could be used through EAP. EAP was then introduced into wireless. There was EAP TLS, which improved security a bit. I mentioned before protected PEEP, Microsoft PEEP. And there's various components that are used in 802.1x authentication. You have your supplicant, your authenticator, and your authentication server. So your supplicant, and we haven't mentioned Radius, but Radius was, again, another way of performing authorization. So you, as your supplicant or as a device that wants to connect to a network, you attempt to be authorized by a Radius server. Your packets are sent via EAP to the Radius server, and any further traffic is blocked until the server passes an authentication token back, and the server authorizes you, passes the token back, and informs the AP that you're permitted to perform more traffic. WEP, the biggest mistake ever, part of the 802.11b standard, attempted to encrypt traffic on a wireless network until the private keys were leaked. Many vulnerabilities. Its wireless equivalent privacy is not. WPA2 was, and WPA was an improvement again until the keys were discovered. WPA2 was an improvement over that. They use 802.11i standard, or a replacement for WEP. And it improves encryption through the use of TKIP, temporal key integrity protection. So it does an integrity check. It does an initialization vector. God, I want to say it was WPA where the IV was leaked, but I don't remember. So per packet, key mixing, rekeying, and it uses EAP as well. WPS is a way to add devices through a network through the use of a physical button. There was a flaw discovered back in 2011 that allowed an attacker to bypass WPA2 and use WPS without even hitting the physical button to gain access to the network. So what is Wardriving? Driving around with inexpensive hardware and software to detect unsecured APs. Wardriving is not illegal, but using the network resources is illegal. So this is a huge fuzzy area. Google got in trouble for this years ago when it was trying to kick off Google Maps. And Google would drive around with, the cars with the cameras on them. And it was using wireless networks that were around to help, supposedly help build its maps out. And it turns out that they were collecting data. So not only were they scanning for access points, but they were sniffing data and saving it. They lost a Supreme Court case. 2008 or 2011, can't remember, but and they ended up having to pay someone some money or something, but it left this kind of fuzzy gray legal area of, is this illegal? Is packet sniffing over wireless networks legal or not? So detecting the wireless networks, probably not illegal. Sniffing the packets of those networks, which, and if you're Wardriving, sometimes that's what you have to do to find some of the hidden networks. Possibly, right? And they lost a civil case. No one was criminally charged. I'm not a lawyer, but read about it, look it up. Just be careful when you're doing it if you choose to do it. Or again, consult someone who knows. How does this work? You drive around with an antenna and you basically listen for networks. That's all this is, right? They give a fancy name to it. I mean, it can be difficult and complicated, but this also was a thing to do 5-10 years ago. People typically don't do this that much now. But if you're doing it, if you're trying to get into a company, if you're trying to perform some work for them, The concept of Wardriving, where it is wireless network discovery, is something you want to do as part of a contract. Vistumbler, written for Windows, designed to verify WLAN configurations, find other wireless networks. This is key here, find unauthorized access points. And you can hook it up to a GPS so you can map the various wireless locations. So here's an example of configuring the GPS settings in Vistumbler in the settings dialog. And, you basically flip this on in Windows, you walk around, and it logs the SSID of the wireless networks they find, the MAC address of the access point, manufacturer of the access point, what you'd get from the MAC address, the channel that it found, the signal strength, the encryption. And you can, you can detect it from miles away, but it also depends on what band you're using. You can do that from 2.4. You can't do that from 60 gigahertz. It's just not going to work unless you can really squelch the noise and the interference coming from everything else. Kismet and Air Snort and Air Crack is what I used back in the day. Written by Mike Kershaw, runs on basically everything. It's a sniffer and an IDS, so it can sniff various traffic along the 802.11 protocols. And it works with Wireshark, works with TCP dump for data logging, Air Snort and Air Crack, and it can detect various network ranges and hidden SSIDs. Kismet, again, one of the standards. When you're hacking a wireless network, it's not that much different from hacking a wireless LAN. The only difference is the medium. One uses wires, one uses radio frequencies, right? So to get on it, you have to take a different approach. Once you're on it, it's pretty much the same thing. Aircrack, pineapples, go to Hack 5, and if you want to ever see a pineapple. There's actually a cool picture of this guy walks around at DEF CON every year with a bunch of pineapples strapped to his back. To collect all the wireless data and sniff. Aircrack NG, this is one of the most used tools if you want to access web-enabled WLANs. I think now it takes WPA2, it's 4 days of sniffing to crack the token. This is the Fern Wi-Fi cracker interface. And here's an example of Wi-Fi Pineapple. So we're talking about countermeasures for wireless attacks. You want to make it not only difficult for Wardriving, but you want to be able to figure out who's doing it to you. And you can do that through the concept of honeypots, Black Alchemy's fake AP. You can prevent radio waves from entering or leaving the building. So you can basically make your building a Faraday cage. The other problem with that is, though, obviously you're going to block out other frequencies if you don't do that properly. So if you do it, you also, if you're not careful, people can't even use their cell phones. You can use a router to filter unauthorized access as well. So that's one countermeasure. Use an authentication server, so EAP. You can use Radius, make sure people are logged in if they want to use the network. You can use the concept of a DMZ and use a firewall to keep AP traffic out of the physical network, making sure that you've upgraded to WPA2 and replace hardware that can't be upgraded. Use static IP addresses instead of DHCP, disable WPS, and change the default SSID and disable SSID broadcast. But again, that's security through obscurity, that last one. So what did we talk about? We talked a little bit about RF, talked about WNICs and the components of wireless networking protocols, SSIDs, so the service set identifiers. We talked about IEEE, their standards, the 802.11 standards for wireless networking. We talked about BSSs, the collection of all devices on a wireless network, and the BSA, which is essentially the coverage area for an AP. We talked about basic WLAN technologies, infrared, narrowband, spread spectrum, Bluetooth, WEP, WPA, WPA2, Authentication, Wardriving, WLANs, and the various countermeasures that can be used to prevent people from getting on your wireless networks.